Okay, today so we will have an example in using the first law of thermodynamics. Okay, so our first example is how to evaluate work due to an expansion of a piston cylinder assembly. Okay, so this is the problem, and you can find this one on page 53, example 2.1. Okay, so I'll read the problem. A gas in a piston cylinder assembly undergoes an expansion process for which the relationship between pressure and volume is given by PB to the n equals constant. Okay, so if we will going to draw the PB diagram of this problem. Okay, so initially you have a initial condition. You have this is your point 1 with now the initial pressure is 3 bar, so this is 3. Okay, and volume is 0.1. Ang unit niya is m cube. Okay, this is your initial condition. And then during expansion, so okay, so the piston cylinder, the volume expands. So ma-increase ang volume ani. So ano siya? V2 is 0.2. But the pressure decreases kay inversely proportional man yung relationship nila ni. Okay? So the final pressure is not given, but compute mo na nimo. Say for example, nadiri. Okay, this is 0.2. Okay? No, so yun niya dire, ang process nimo undergoes a polytropic process, PB to the n equals constant. No? Therefore, the work done by the system, so since this is an expansion process, we can predict na positive work atong makuha ni, no? Dapat positive. So ang work done is just kaning the area under this curve. Work is just integral of P dB. Okay, so we are now going to evaluate the work. So para ma-evaluate nimo ning expression, kinahanglan mangita ka og relationship, no? Ang pressure nimo express nimo in terms of volume para solve nimo. So gamito na nimo using this one. Your P is just C over V to the N. So you have C dB over V to the N. Okay, or this is just C of B to the N, negative N, negative N. Okay, so morning negative N plus 1 over 1 minus N, or negative N, from V1 to V2. Okay? So muna siya. Or nalangin mo 1 minus N. 1 minus So this becomes constant V sub 2, okay, 1 minus n, and then C, okay, C V sub 1 minus n over 1 minus n. Okay, but ito na rin i-reasoning ini nga diagram. Reasoning diagram. But we know nga ang kanyang constant is just kanang C, it's either P2 B2 to the n is just equal to P1 B1 to the n. Okay? So since V2 man eh, kanitong gamiton po. May mo na lining P2 B2 B2 n 1 minus n minus kani V1 man kani po itong gamiton. Anyway, same naman sila. B1 B1 to the n B1 1 minus n over 1 minus n. Now, so n i-add ni mong exponent, so may mura na yung P2 B2 minus P1 B1 1 minus n. Okay, so na-simplify, no? So given ka n 1.5, given ka og P1 B1 V2 P2 na lang kulang, so ito na siyang solve on using this one, this relation. P2 is just P1 times B1 over B2 to the n. So P1 is 3 bar B1 0.1 over 0.2 raised to the 1.5. Okay? And then kuha ni mo nga ang P2 is just 0.1 divided 0.2 raised to the 1.5 times 3. 1.06 bar. Okay? 1.06 bar. Therefore, the work is just nasa be consistent sa unit. 1.06 bar times 0.2 m cube. Okay? M cube. By the way, ito sanin ko na. .06 times 0.2 minus 3 times 0.1. Ang unit alin niya over 1 minus 1.5. Unit niya is bar m cube. Okay? But atong target is kilojoule. Kilojoule is just kilo Newton meter. Right? So ato ni siyang ang bar convert na to kPa. 1 bar is just 10 to the 2 kilonewton per m square. times m cube. Okay? Mahimo na ning mahimo na din ning kilojoule. Okay, so i-multiply ni 1.06 times 0.2 times 0.1 divided by 0.5. Okay, times 100, 17.6 kilojoule. Okay, the unit the value is positive because this is expansion or work done by the system. Okay, so I think napasalain nga mga and there is a book, no? Kamo na mag-solve ana. I think so paano man siya? Dali ron sa masabtan. You just need to practice. Okay, so let's have another example. You have example 2.2. It's found in your book, and this is about evaluating the net heat transfer using the first law of thermodynamics. Okay, so the problem is you have 4 kilograms of a certain gas, so wala gini mo sa nga gas, is contained within a piston cylinder assembly. The gas undergoes a process for which the pressure-volume relationship is PV to the 1.5 is equal to constant. So, basically, parang continuation ito sa problem number 1. No? Almost the same given. Okay? The initial pressure is 3 bar. Initial volume 0.1 m3. Final volume 0.2 m3. But this time, you are given the change in internal energy. U2 minus U1 is equal to negative 4.6 kilojoule per kilogram. So the question is, determine the net heat transfer for the process in kilojoule. Okay? So, kung i-draw natin yung diagram, this is your piston cylinder assembly. Okay? So initially, as I contain ng gas dari. Initial pressure, initial volume. Okay? And then the gas will expand. So in return na ay heat transfer to the surrounding. No? So ang question niya is, how much is the net heat transfer? Okay? How much is the net heat transfer? So how do you solve that one is by using the first law of thermodynamics. Okay? You have the change in energy of a system. So this is your system, meaning gas within the cylinder assembly is just equal to the net heat transfer minus the work done or by the system. Okay, so ang energy niyo is composed of change in potential plus change in kinetic plus change in internal energy. Okay? But yun sa problem, negligible lang ang change sa potential and kinetic. So, zero ni, negligible. Therefore, ang Q na to is just the change in internal energy plus work. Okay? So, given ang change in internal energy, negative 4.6 kilojoule per kilogram. And then, ang work is, based sa katong example 2.1, work is positive 17.6. Positive 17.6 kilojoule. Right? So, kilojoule ni. Okay. Okay. Kilojoule per kilogram, kilojoule, dili na ma-add. So, ang tumbuhaton is, okay, ang given man good specific internal energy. Change in specific internal energy. So, kinanglan mo ni multiply ka og mass. No? Multiply ka og mass. Ang mass, anyway, ang mass is given man, 4 kg. So, times ang tag 4 diri. And, kuha na tayo na ito ang result, which is negative 0.8 kilojoule. Okay? Negative 0.8. Okay, so negative. Okay ra ba na siya? Mali ba na ang answer? Negative. Now, negative siya because it is going out of the system. So, always remember ang convention. So, ang positive, ang meaning ani is pagawas. No? So, okay na siya. Mao na siya answer, no? So, using the first law of thermodynamics, we are able to account, no? We are able to account ang padulong ang energy. Okay? So, unsa may pasabot ani? Meaning ani, ang kaning imong system contains 18.4 kilojoule of energy kani kung compute nimo ni, no? So using sa first law of thermodynamics, we are able to account mo din ni 17.6 ra ang work na nahimo. Ang uban kung ano siya, nahimo ra sang waste heat, no, to the surrounding, o in kani ang value 0.8 kilojoule, no? So makita nato no ang importance sa first law of thermodynamics. So I think send rasa and then practice solving the problems in the book. Okay, so let's have another example to demonstrate how to use the first law of thermodynamics. Okay, so this is found in example 2.4 in your book. Okay, so the problem is during steady state operation, a gearbox receives 60 kilowatt of power through the input shaft. So this is the input shaft. Okay, so this is the gearbox and delivers power through the output shaft. So this is the output shaft. For the gearbox as the system, no, so this statement is important. So meaning ana kani ato ang nato ni siya og system boundary. Importante kaning system boundary, as we will learn later on. For the gearbox as the system, the rate of energy transfer by convection is can be found using this formula. Okay, so these are the given. So the boundary temperature TB, muna ang boundary temperature sa gearbox, and then TF, muna ang temperature sa air. Okay, there is ang air ni mo diri, TF. And for the gearbox as the system, evaluate the heat transfer rate and the power delivered through the output shaft in kilowatts. Okay, so we are to determine the heat rate of heat transfer in kilowatts. So, dali na siya. We will use this one. Given naman eh. Okay, so our Q is just 0.171 kilowatt per m squared Kelvin times area 1 m squared times 300 minus TF. Oh, by the way, this is negative. Okay, so negative 300 minus 293 Kelvin. Okay, so now na ito kung makancel. So nabilin is kilowatts. Okay, therefore kung mo na i-calculate, that would give you negative 1.2 kilowatts. Okay, why negative? Because paggawas man siya going out of the system. Okay, so muna siya. And then how are we so ito pag-determine ang power nga ni gawas diri sa output shaft nimo. Output shaft. Okay, so para makuha nato na siya nga power, we need to apply the energy balance. Okay, since kilowatt ang unit ani, so this is per unit time, no? Kani itong gamiton per unit time ni. Now yun diri for a steady state operation, yung ikag steady state, no? Kung unsa ang energy sa point initial condition mo sa final, the same na sila, therefore no change in total energy, so zero na siya. Therefore may tabuan ni your Q is just equal to work, okay, or your rate of energy transfer by work is just equal to Q. Okay, now so naakay work in, no, sa input, and then work out. So diri mo play ang importance sa imong system boundary. Okay, so based sa imong system boundary, sa ganito may notation na to ani, kung pasulod ang work negative, so therefore kanang 60 is just negative na siya, negative 60 kilowatt sulod man na, plus work out, work done by the system positive is equal to Q, negative 1.2 kilowatt. Therefore your output ng work is pila man? Transfer na to sa pikas, may morning 60 minus 1.2 or 58.8. Okay? 58.8 kilowatt. May sulat na to. Dari work output dapat makakuha tag positive value naman kay paggawas man ni sa system. Kung negative mo nakuha na, there is something wrong. No, so ninaw na siya pag double check. That's it. Okay, so makita na to nga from 60 na reduce to 58.8 nga naman because of energy transfer by heat, no? heat loss. Manginit man imong gears. So naay energy nga nawala or nigawas sa imong system. So mao na siya. That is the use of the first law of thermodynamics.